look at the graphs of polynomials. This is hard to see here, but I screen captured the drop down so you could kind of see what it's asking for. Okay, so there's several different questions here. They're just asking you to identify based on the long run behavior, the end behavior. Is this graph going to be an even power or an odd power? Again, we talked about how those break down. Okay? If you're looking at an odd degree versus an even degree function, and this is true for all functions, okay? So both polynomials as well as the non-polynomials. Okay? But when we're looking for the graphs of these polynomials, if your leading coefficient is positive, versus negative, okay, so again, what we are looking at here is you don't have to try to memorize these if you can just recreate with the simplest example you can find. Okay, so a positive leading coefficient with an odd degree is y equals x. So y equals x looks like this. And so you can see the end behavior up to the right, down to the left. If you have an even degree with a positive leading coefficient, the simplest even degree function you can think of is x squared, which is a parabola, U-shape. Okay? And then the negative, if we go back to our transformation rules, the negative is just going to flip our graph vertically across that x-axis. So this point flips down, and then here our U-shape parabola flips down. And so those give us our negative leading coefficients for both odd and even degree polynomials. Okay, so what I want you to do is, in each of these examples up here, just the ones with the graphs, okay, I want you to identify whether you think that graph has a positive or negative leading coefficient, and whether you think it has an even power or an odd power based on these tendencies that you see down here. Okay, so go ahead and see if you can answer those those four problems. All right, so when you're looking at this first one, we see it goes up. When the ends both go in the same direction, you're dealing with an even power function, and we're going to talk about polynomials here, so even powered polynomial. So you know that it's even power, and because it's up, it's positive, and so you get a positive leading coefficient with an even power. Okay, the next one, again, the end behavior, they both point in the same direction, so it's an even function, or an even power. Okay, and so when you're looking at this, they both open down. Evens that open down have a negative leading coefficient, so you have a negative leading coefficient with an even power. Okay, the next one, we see that the end behavior is opposite one another, so that means that the highest degree is going to be an odd number. Okay, so you're dealing with an odd power for your degree, or for your leading term. And here we're looking at, if it goes up to the right, it's positive, down to the right, it's negative. This one goes down to the right. So we have a negative leading coefficient and an odd power. Okay, and then finally, the last one, again, when we look at our end behavior, they go in the same direction, meaning it's an even power. Okay, and since it's both going in the downward direction, you have a negative leading coefficient. And so that would be your relationships.